Hey everybody, we are going to be starting off with page 3. So open up to page 3 in your packet. What we're going to do today is review some of the stuff that we talked about yesterday and then kind of follow up with some factoring. So what we're going to do is review everything we talked about yesterday and then follow up with some extra work on factoring. So let's take a look at question 9. The first thing that we're looking for is the degree of this polynomial. And the way that you find a degree when it's in factored form, okay, so we'll talk about the difference between factored form and standard form. But factored form is when you have x plus something times x minus something times x minus something. So the way we find the degree is simply to add together all of these exponents. So your degree is going to be 3 plus 1 plus 1. So degree is 3 plus 1 plus 1, which is 5. So your degree for the first one is 5, and you get that by adding together all of the exponents. So then we need to talk about the zeros. Essentially, we're asking ourselves, what does x need to equal for that, in this case, x plus 1, to be 0? So if we want to make x plus 1 equal to 0, well, we would need to have x equal negative 1. So our first 0 is negative 1. And then we look at this number up top, which is the multiplicity. The multiplicity tells us how many times that 0 shows up. So sometimes you'll actually see someone, instead of saying that you have a 0 of negative 1 and moving on, sometimes they'll actually write it 3 times to say that it has a multiplicity of 3. Our next 0 is going to come from this x minus 2. So what do I need to plug in for x to make x minus 2 0? That's a 2. And lastly, what do we plug into x to make x minus 1 0? That's a 1. If you haven't noticed, essentially what we're doing is taking the number and merely switching the sign. Now, our next task is to find out the end behavior. The end behavior comes directly from the degree and the leading coefficient. If our degree is odd, like 5, it's either going to be an increasing or a decreasing function. If that leading coefficient is positive, it's going to be increasing. If it's negative, it's going to be decreasing. So in this case, since our leading coefficient or our first number is positive, it's not there, so we assume it's positive, and our degree is odd, we know that our end behavior is going to look something like a standard disco, or an increasing disco, as I like to call it. So here's what we do with that. That means that this graph is going to start in the bottom left, and it's going to end in the top right. So I kind of picture my graph there. It's going to start in the bottom left somewhere, end in the top right somewhere, and do a bunch of crazy stuff in between. So to find out exactly what it does, first we're going to look at our zeros. So our first 0 is at negative 1. We have a 0 at 1 and a 0 at 2. So what I'm going to do is I'm going to use that multiplicity, that number of times the 0 shows up, to talk about or figure out how does it cross through that point. And as a reminder of what we did the other day, if you have a multiplicity of 1, so if we have something like x minus a to the first, what that tells us is the graph is going to go straight through the x-axis. If we have a multiplicity of 2, that tells us it's going to look like a parabola. And if we have a multiplicity of 3, that means it's going to have that disco shape as we go through. Oops. going to have that disco shape as we pass through the x-axis. So with that in mind, I'm going to look at my multiplicities. So I see that -1 has a multiplicity of 3. So that means when I come up from the bottom left and I hit -1, I'm going to pass through with that disco shape. At 1, I have a multiplicity of 1, so I'm going to go straight through. And at 2, I also have a multiplicity of 1, so again, I'm going to go straight through. And now I basically connect the dots. I come up from the bottom, I disco at -1, I go straight through at +1, straight through at +2, and head off to infinity. Now, if you look in the middle, it doesn't really matter how high you go. There are ways to figure out what the y-intercept would be, but for the purposes of this class, just all I really care about is what's happening at your x-intercepts. So, try to fill out the information for number 10. As you do it, I'm going to try to do it in front of you, and then you can check your answers with me. So try to find the degree, the 0, end behavior in the graph, and then you can check your answer with mine. All right, so let's talk about where this stuff came from. To find your degree, essentially all you're doing is taking those exponents and adding them together. So I take the exponent of 3, the exponent of 2, add them together, and I get a degree of 5. For the zeros, what do I plug into x to make x minus 1 or x plus 1 0? Well, I'd have to plug in a -1. Davis, why did you do 3 -1s? Well, I have a multiplicity of 3, so that's where I get 3 -1s from. Technically, you can just put one of them if you'd like. Some people like to list all of them. As for the second one, what does x have to be to make x minus 2 0? Well, that would be +2. And since our multiplicity is 2, you could essentially say we have 2 of them. Now, end behavior. Since I have a degree of 5, I know it's a disco shape, and since my leading coefficient is positive, it is going to be increasing. At this point, the biggest thing we got to worry about is now how are we going to pass through each of these x-intercepts? Since the multiplicity at -1 is 3, we are going to pass through like a cubic, like that disco shape. So we're going to go up, then we are going to disco through at -1. Well, then you're like, well, how are we going to get back up here if we have to go back through this x-intercept? Well, this multiplicity for 2 is 2. So that tells us instead of going straight through, instead of discoing through, we are actually just going to tap it like a parabola. And after we tap it, see how we didn't cross the x-axis? We're just going to head back up towards infinity. And so this is what you should have gotten for your second graph. You get a disk go through at -1, comes back around in parabolas at 2, and then heads off to infinity. We are going to skip number 11 simply because I feel like it, and we are actually going to move on to page, what page is this? It is not page 43, it is page 5. So we're going to jump up to page 5. Okay? Move on to page 5. We're actually going to ignore that one as well. We'll just jump right to number 2. So let's look at number 2. Okay? Again, already in factored form. We have, looks like 3 different factors. Again, anything that's x plus or minus a number is known as a factor. So anything that we can multiply together to equal our function is a factor. Now what we need to find are our x-intercepts. What would x need to be for each of these pieces to equal 0? Well, the simplest ones are the parts in parentheses. What would I plug into x minus 4 to make this equal 0? Well, you'd have to plug in a 4, because 4 minus 4 is 0. For x minus 2, you'd plug in a 2, and this is the one that actually throws everybody off. What would I plug in for x to make negative x equal 0? Well, what do I plug in for x to make x 0? That would be a 0. Now we have to talk about end behavior. The way that we find end behavior is to start by talking about degree. What is the degree of the polynomial? Because if I know the degree and I know the leading coefficient, I know what the end behavior is. So let's look at the degree. To find the degree, I simply add together all of the exponents on x. So I have a degree of 3. As for my leading coefficient, well, is that first number, that first thing in front of the x, a positive number or a negative number? That's really all I care about. And in this case, I have a negative number. So my leading coefficient is negative. So here's what that tells me. Since my degree is 3, I know that my graph is a disco. It's got that disco shape to it. Then, since my leading coefficient is negative, I know that it's going to be decreasing. So what that means is it's going to start in the top left and it's going to end in the bottom right. So for left end behavior, as x approaches negative infinity, which means as we go left on our graph, the graph is going to be going up to positive infinity. As x approaches positive infinity means as we go right, my graph is going down, so we say f of x approaches negative infinity. So that's the basic shape of the graph. Now to finish it off, all we have to do is make a little spot for each of our x-intercepts, 0, 2, and 4. And I'm actually going to move this over a little bit. Here. And since each of them have a multiplicity of 1, I know that I'm going to go straight through the x-axis every time I reach one of these x-intercepts. So I'm going to start up here. I'm going to go straight through at 0, straight through at 2, straight through at 4. Again, the way I know that is I look at the factor that each x-intercept came from, and I look at the exponent. If it's a 1, you go straight through. 2, you parabola. 3, you disco. So let's turn the page. Not page 44. This should be page 6 for you guys. Now, the difference between this one and some of the previous ones is that we have not fully factored. So the only thing that makes today's lesson different from yesterday is we're actually going to have to do a little bit of factoring. Now, since there are 3 terms, I look for anything that x squared, 4x, and 4 have in common. I don't see anything. And since we have 3 terms, this is my multiply, add, factoring. So what are 2 numbers that multiply to get positive 4 and add to get 4? Well, 2 and 2. So what I get is x. Where did that x come from? It's the same x that was out front, times x plus 2 times x plus 2. And where did that come from? Well, I factored. Now, the nice thing, x plus 2 times x plus 2 is just x plus 2 squared. So we actually have a multiplicity of 2. So what we're going to do now is just fill in the rest of the gaps. Looking at x-intercepts, well, what would x need to be for x to be 0? Well, 0. Again, a lot of people freak out of that. Since we just have an x, you plug in 0, everything happens, everything works out fine. X plus 2, well, to make this 0, I'd have to plug in a negative 2, and we happen to have a multiplicity of 2. So like I said, you can either just write negative 2 and keep track of the multiplicity, or you can write it twice. To find end behavior, again, what you need to do is look at degree. You have to look for the degree. To find the degree, you simply add the exponents together. Here I have a 1, here I have a 2, so my degree is 3. And my leading coefficient, that first number, happens to be positive. So that tells me that my graph is going to be an increasing disco. Since my degree is odd, I know it's a disco. The plus tells me it's increasing. That means that for my graph, it's going to start in the bottom left, and it's going to end in the top right. So we can say as x approaches negative infinity, f of x approaches negative infinity as well. As x approaches positive infinity, f of x approaches positive infinity. So we have zeros at negative 2 and 0. To figure out how it crosses through negative 2, or if it crosses through negative 2, we look at the multiplicity. Since our multiplicity is 2, that means that when we get to 2, we're not going to pass through it. We're going to tap it like a parabola would. But when we get to 0, since the multiplicity is 1, we're going to go straight through at 0 and head off to infinity. So again, what happens at the x-intercepts is solely based on your multiplicity. A 1 goes straight through, a 2 will go like a parabola, and a 3 will do your disco. Now for number 4, you'll notice 2 things. First of all, this is in what's called standard form. Standard form Standard form is when it's not factored whatsoever. It's in its basic form. Everything's all multiplied out. You only have addition and subtraction. When you have standard form, your degree is actually really easy to find. Your degree is just the biggest exponent. So when you're in factored form, like on the left, you add together your exponents. When you're in standard form, where it's all at addition and subtraction, all you do is look at the highest exponent. But now to find the x-intercepts, we actually do need to factor x cubed minus x squared. And the first thing I look for when I'm factoring is, do they have anything in common? And in this case, both of them have 2 x's. So I'm going to factor out an x squared. If I take 2 x's out of x cubed, I have 1 left. If I take 2 x's out of x squared, well, remember, I never have 0. Never wind up with 0. If I think I should put a 0, I have a 1. So since this is 1x squared, if I take away the x squared, I'm left with just a 1. So now my x-intercepts are 0 and 1. 0 because I plug in 0 for x, and 0 squared is 0. 1 for here, 1 minus 1 is 0. And as we've usually done, if you want to, you can actually put 0 twice, since it has a multiplicity of 2. And we can go from there. End behavior, since our degree is 3, it's going to be a disco. And since our leading coefficient, that very first term, since that's positive, I know it's going to be an increasing disco. So I'll start at the bottom left. I will finish in the top right, which means as x approaches negative infinity, I'm at negative infinity. As x approaches positive infinity, I'm at positive infinity. When I hit and then my zeros are 0 and 1. And notice I am labeling my x-axis there. Pause for you to catch up if you're writing with me. All right, again, the big part of this whole chapter, how does it pass through that x-intercept of 0? Well, since my multiplicity is 2, that tells me I'm not going to pass through at 0. What I'm going to do is I'm going to tangent the x-axis and make it look like a parabola. Then when I get to 1, since the multiplicity is 1, I'm going to go straight through like a line. Now if it curves a little as you go through, that's fine, because it is a curve. My pen is acting weird. But the idea is that you pass straight through instead of just tangenting the x-axis. So we got 2 more in front of us. Well, let me actually hold off here. Let you copy this down if you're still following. We've got 2 more in front of us just to get a little bit of extra practice in. And like I said, I want to do some extra factoring stuff, and you'll see that for the next page. So we go to the next page. And we got 2 really nice factoring questions here. So for the first one, let's get this out of the way. For the first one. Again, I notice that this is in standard form because there is no multiplication. If it is all addition and subtraction, you are in standard form. And in standard form, I don't need to add exponents. All I do is I take the biggest exponent there, which happens to be a 4, and that is my degree. But in order to find the x-intercepts, I need to factor. And so I look at this and I notice two things. Number one, there's two terms. So I'm either going to use SOAP or I'm going to use that plus minus rule. And as I look, I have an even exponent. So that tells me I am not going to use SOAP, I'm going to use the plus minus rule. So if I have two perfect squares, I can take the square root of each. First set of parentheses gets a plus, second set gets a minus. So I take a look at x to the fourth, I take the square root of that, which gets me x squared. So I have an x squared for both. Then I have a 16, so I take the square root of 16, and I get a 4 as the second part of both. And what goes in between? Well, plus, minus. But then I have to look at my answers. Well, here, I still have x squared plus 4. Hey, look, x squared is a perfect square, and 4 is a perfect square. So can't we do it again? Well, unfortunately, no. And here's the entire reason why. If you have a plus sign in between, you cannot factor further. But look on the right. I have two perfect squares, x squared and 4, and I have a minus sign in between. What that tells me is I can actually do my plus minus rule one more time. So I'm going to take the square root of x squared, and I get x. I take the square root of 4, I get 2, and what goes in between is plus minus. So this one is a tough factoring question. Again, you can still talk about degree. So that degree is 2, that's 1, that's 1. Add these together, we still get 4, so it still works. And as we look at x-intercepts, well, we see -2 and 2 for these guys, but for the x squared plus 4, there actually isn't anything I can do with that. So there actually is no x-intercept. This actually is imaginary. And since you have imaginary answers for this guy, we actually don't have x-intercepts there. So really, all this becomes is a -2 with multiplicity 1, +2 with multiplicity 1. We do our end behavior. So since we have a degree of 4, I know it's going to look like a parabola. And since my leading coefficient is positive, it's going to be an upward-facing parabola, which means left end and right end are both heading to positive infinity, and we just fill in our graph. -2, +2. Starts up left, ends up left. And since both of these have an exponent of 1, we go straight through, curve around, and straight through. All right, here's our last one. Now, for our last one, I do need you to factor. So the first type of factoring I look for is what do they have in common. So take a minute, see if they have anything in common, and factor out any common factors between all three of them. Now what you should notice is that you have x as a common factor amongst all three of these. Oh, and that's a minus 3. So if I factor out an x, I get x squared minus x minus 3. Or sorry, minus 2x minus 3. You'll also notice that there's a lot of stuff left in here. So let's see if we can actually factor it again. And I'm going to get rid of this whole x thing, since that does not apply to me. So we're going to look at this top right, and we're going to see if we can factor this. Now, since there are 3 terms, what I'm going to do is my standard type of factoring. Are there any things that multiply to get negative 3 and add to get negative 2? Well, we should find that negative 3 times positive 1 multiplies to get negative 3 and adds to get negative 2. So that is our final function in factored form, because all of those are factors. To find our x-intercepts, well, since there's an x out front that's by itself, we know one of them's 0. Because to make x 0, we just plug in 0. To make x plus 1 0, we'd plug in negative 1. To make x minus 3 0, we would plug in 3. So those are our 3 x-intercepts, and they all happen to have a multiplicity of 1. Since they all have a multiplicity of 1, and you could have gotten this right from the beginning, we have a degree of 3. That's the highest exponent in standard form, and that's all of our exponents added together in factored form. Our leading coefficient is positive, so we know it's going to be increasing. So our left-end behavior, on the left side, f of x is at negative infinity, and at the right side, f of x is at positive infinity. So now all we really need to do is label our graph, put in our end behaviors, and connect the dots. So since all of my degrees are 1, I will go straight through negative 1, straight through 0, and straight through 3. So that's how we factor and graph polynomials. Your first step should be look to see if you can factor anything and put it in factored form. After you put it in factored form, find out your x-intercepts by asking what would x have to equal to make that factor equal 0. And then you look at your multiplicities. And just as a review again, because I am all about reviewing this idea, considering it is the major topic for this chapter. If your multiplicity is 1, you go straight through the 0. If your multiplicity is 2, you tangent the 0. It can either be on the top or on the bottom. Just depends on how you're connecting your dots. So if you started at the bottom, you'll tangent the bottom. If you started up at the top, you'll have your parabola up top. And finally, if you have a 3rd degree, you will disco through. And you can actually, again, you can disco through both ways. You can actually go straight through both ways. It just depends on where you're starting from. So if you start up here, you go straight through, you would tangent, you would disco. If you start from the bottom left, you would go straight through, tangent, this go. So it's really a complicated game of connect the dots. I hope that clarifies most of your questions. If not, we're going to be covering this one or two more times or a couple more times over the next week, and hopefully we will clarify everything then.